Hello, I'm Stefano Cavalli, CSO of Genio, partner for the industrialization of the SMIT technology. In this moment, we are in the Genio's laboratories located in Verona, Italy. In this video, we are about to present to you the results of the preliminary laboratory asseveration campaign of the scientific principle of the SMIT technology. The results of this asseveration campaign provide us with a solid scientific background in order to develop the next engineering and industrialization process. Starting from these results, we can be pretty sure that we can accomplish the engineering phase within the next 2 years. And the next step regarding the realization of the pilot plant of the size of 2,000 cubic meters per day of desalinated water within the next 3 years. What you can see now is the experimental setup of the SMIT cell. What you can see in the middle is the SMIT cell. The SMIT cell is fitted with 3 water circuits. The first one is the salt circuits. The water solution is a sodium chloride water solution of 57 grams per liter. The second one is the acid circuits. And the third is the base circuits. The cell is also fitted with hydrogen stored in a metal hydride bottle and with oxygen provided by an air pump. To the cell is also wired a load simulator and all the measurement system is made with a voltmeter, with an amperometer, and with a multimeter that allow us to measure the salt content and the pH of the two solutions. Now we are going to start with the experiment. First of all, we are going to measure the starting point. The first one is going to be the salt content of the salt solution. As you can see on the multimeter, the salt content is around 56.4 gram per liter of sodium chloride. Second of all, we are going to take a measurement of the pH of the two solutions. As you can see now, the NaOH does not contain water. That's why the NaOH is going to be produced on a solid state in the electrodes and will be extracted at the end of the experiment by washing the electrodes. Now, first of all, we take the pH of the acid solution, and as you can see, it's going to be around 5. That's the pH of the deionized water. As the smiling face tells us, the pH is what expected, around 5. Now we take the pH of the salt solution . And as you can see, also in this case, the pH is going to be around 5. In this case, 5.4. Now, we take out the sensors and we can switch on the cell. First of all, we switch on the air feeder and the hydrogen. Okay. Second of all, we switch on the repumping apparatus. Third of all, we are going to switch on the load, the electric load. Doing this, the electric circuit is going to be closed on a load of around 20 ohm. Now, as you can see on the voltmeter and on the amperometer, the cell is producing a current, an electric current, and an electric voltage. That's mean that the cell is producing electric power. Now, the electric power is produced by the desalination of the water. We leave the equipment working for a little while, and then we will be back in order to take the salt and the pH measurements. As you can see, after a few minutes, the salt content is low down to 56.1, and now we proceed in washing the NaOH electrode, injecting a little amount of water in the electrode. Okay, now, as we can see, this solution is going to be blue, that is on the base scale, and the acid solution is going to be around the orange, that is on the acid scale. Now, the only elements inside the salt are chloride and sodium, and the only elements that can produce a base solution is sodium hydroxide. On the other side, the only elements that can produce an acid solution is chlorhydric acid. The whole experiment take something like three hours and a half. This time is due to the small dimension of the electrodes inside the cell that are more or less 4 square centimeters. As we can see, the salt content of the salt solution is around 35 grams per liter. That is on the average the amount of salt contained in seawater. So this water is now possible to be treated by a reverse osmosis plant. As we can see, the cell still produces current and voltage, and now we can check the output of the cell, so the NaOH and the acid, chlorhydric acid. First of all, we check it out with the multimeter. First of all, we check the base solution. As you can see, the pH is higher than 11, so very base. And now we can check it out, the acid solution, that, as you can see, is lower than 2. Okay. We can also check the pH value using the pH indicator. Now we see the base solution. As you can see, it's deep blue, that is on the base scale. And we can check it out, the acid one. that is very red on the acid scale. The experiment performed successfully demonstrates that the electrochemical apparatus realized is able to reproduce the desired reaction. During the experiment, we have reduced the salt content in a water-salt solution, producing an acid water solution containing chlorhydric acid, a base water solution containing sodium hydroxide, and a certain amount of electric energy. The same experiment demonstrates a very strong correlation between the desalination capability and the electric current produced, with a conversion parameter close to 94%. That means that the 94% of electric current produced have actively extracted ions from the water-salt solution. Furthermore, the experiment demonstrated that the electrochemical apparatus is able to treat brine depleted by reverse osmosis plants in order to reduce the salt amount to a similar quantity of salt found in seawater. The realization of a reverse osmosis desalination plant equipped with a SMIT brain processor can reduce down to zero the brine production, producing desalinated water with a quality certified all over the world, eliminating the electric energy consumption of the reverse osmosis and producing chemicals that might be used both for commercial purposes or for the production of sodium hypochlorite usable for the disinfection of drinkable water. Thank you for your attention from Stefano Cavalli and all the Genius staff. We hope you enjoyed the video, and for any question you can contact us through our email address.